I first met Taha in actually 2014. We were in the lab and starting to get a little bit into Wikipedia data, and Taha already had some excellent papers about it. And we thought we would invite him and to give us a bit of information, and that helped us a lot about understanding it. He was also a contributor at the time, and if he still continue that. But yeah, he just gave us a lot of information about that. And then he continued to do really amazing work outside of Wikipedia and with it as well. You'll see some of it here. He has positions in both the computational and social science and humanities and social science departments in Oxford University. And he's also a faculty fellow at Alan Turing Institute for Data Science. So we're very happy to have him here.
Thank you very much, Luigi. It's a great honor to be here again after a few years. Thank you very much. Well, I'm going to talk about armies of bots and humans in the lab. This title is adopted from a paper, or stolen from a paper, which is rather old. 1969, Maurice Zidlich has written this paper titled, "Can you really study an army in the lab?" Basically, the paper argues that no, it's difficult to put huge armies in the lab, and the point being that it's difficult to study conflict or laws or the negative sides of human interactions in a way that we are used to in natural sciences. You know, control experiments are difficult, even observational data are not reliable or very sparse. You don't want to repeat the Second World War again just to have better statistics. This kind of things was the case, at least in 1969 we can say, quite confidently, but today of course things are very different. We do live in labs, we do live in online laboratories or platforms, we do basically most of our daily activities online or in digital world where we leave digital traces, and those traces could be used to analyze our behavior in a similar way that is being done in natural sciences to study natural phenomena. Well, particularly I'm interested in negative social interactions. You know, I'm in the Network Science Institute, and we all love networks, and we have studied networks in many different disciplines or different sectors. In social networks, we are more, we have studied, I guess, more positive sorts of interactions between people, right? Collaboration networks, friendship networks, etc. But of course, you can think of negative interaction networks like disagreement networks, disapproval, or distrust. These networks are equally important. Maybe the reason that they're not that much studied is just because it's difficult to have data on negative interactions, or it's difficult to observe negative interactions. You know, classic sociology network analysis would be based on sociograms. You would sit with the subject and ask them to name their friends and to draw the network. It's very difficult to sit with someone and ask them, name your enemies, and let them draw the network of your enemies. People are reluctant to express their negative emotions or negative interactions with others. That's the first problem, of course. The other issue in relation to negative interactions is that they are, as I said, equally important. They could influence your well-being, your work, personal behavior or feelings. There has been research showing that negative interactions are equally important as positive interactions in our performance. And then when you look at the theory, for example, one of the biggest theories in psychology, social psychology, is a balance theory, which is basically enemy of my enemy is my friend and other combinations. Well, we are already talking about side networks or negative interactions. So from the theoretical perspective, it's really important to study negative interactions, whereas again, for obvious reasons, or sometimes not very obvious reasons, negative interactions have been understudied so far. Well, let me show you an example of some sort of negative interaction system. This is the International Pillow Fight Day, and I filmed this in Budapest in 2011. At the time I didn't know that I'm going to present this in Laszlo's lab some years later. But it's a very simple game. Just grab a pillow, come to the venue, and hit whomever you want, and have fun. And it's really fun. I mean, even watching it has been the greatest thing I've done in Budapest for a few years as I did my postdoc there. And you can also, it's very complicated, you know. People come in with their friends, they are too shy to hit strangers, they hit their friends, but then they suddenly hit someone else, and then they start to fight back, and then their friends support them, the age, the size. There are lots of factors here which makes this very interesting, also difficult to study. But my dream experiment would be to pay people to do this for me, and then I could follow them and record the interactions and then study that network. But I'm not sure if the ethical approval would be easy to obtain for such an experiment, so I moved to Wikipedia, which is much less exciting, nevertheless quite similar. Well, I suppose everyone in the room knows what Wikipedia is, but what I would like to know is how many of you have ever edited Wikipedia? Well, that's a good number. Some of you might have experienced something that we call edit bar. Those edit bars are very common. You might not know that. You look at the articles and they look all nice, and some volunteers from all over the world have written them. But behind the scene, these volunteers are really hostile against each other, and there are lots of edit bars happening all the time. Most often, those edit bars are ignited by external events, like Michael Jackson dies, and people want to write about Michael Jackson or his death, and then conflict appears and clashes of opinions. And sometimes edit bars emerge from more or less nowhere. Well, Wikipedia is a collaborative text writing, and if you have ever collaborated with anyone on writing an article, you know it's difficult to track the changes. That's the whole story behind track change topologies. The same in Wikipedia is difficult. It would have been very difficult for us to follow all the changes to see who is doing what. But there is one feature in Wikipedia which made it extremely easy for us, and we're extremely lucky to have that. And that feature is called revert. And that's an inbuilt technology in Wikipedia software which allows you to undo any other edits by just pressing one button. So you don't need to go through the normal process of editing the page, you just undo. It's like the undo button. And it's made primarily to suppress vandalism. You know, someone comes in and deletes the whole page of some problem, you want to immediately revert it back. So you have this button, but people have started to use this button to fight not vandals, but also other committed editors. And why is that so good for us? Because when there is a complete revert, we can detect it just by comparing different revisions, and wherever we find two identical revisions, we know some reversion has happened. And we don't need to be able to read that language even, because it's just comparing different hash codes, the texts. So that made us, that enabled us to study large scale, a large number of articles in many different language editions without even being able to read those languages. Let me show you a totally random example here. This is, the laughter came a bit late. This is the article on Donald Trump, of course. You can look at the history of the article. You can see different revisions coming in here. The date, the username, some basic information, and then you see already within 6 edits that 2 of them have been reversed. Someone has done something here, someone with the username perfectly rational, and then someone else with the username Maxi has reverted the edits to a previous revision, and then perfectly rational has done it again, I suppose, and someone called generalization has reverted it back again. And as I said, it's very easy for us to detect these reverts.
They revert to which edition?
Well, we can see here it's reverted to the last version by Maxi, which would be this one. So this one. And this is a revision to Power EN Wiki, which would be probably somewhere. So we can track, and that's a one-to-one interaction between 2 editors. We can build a network, right, of editors, and the connection would be the reverts. That's easy.
So if there was a sequence of edits, the revert would go to the last person in the sequence? No.
Well, you can think about it. If I reverted 5 previous editions, I'm reverting all those 5 people, really.
Okay.
Otherwise, I could have just reverted to one of those in between dimensions. Okay. But it's a decision to make, and I think we have played with those dimensions. So you can build a network, and we all love networks. This network shows all the reverts that have happened on one article, anarchism in English Wikipedia. Each dot is a user, and 2 editors are connected if they have ever reverted each other. The width of the link is proportional to the number of times that two editors have reverted each other on this particular article. And as you can see, there are a bunch of people who spend their lives reverting each other on anarchism. These few guys here, and then the rest of people have done a few times, so that's probably a scale-free degree distribution if you look at that. So we have this data set. We have extracted this information for 13 different languages. We have some 5 million reverts in a period of about 10 years. Well, this is a messy picture, and we want to quantify this. We have tried many different ways of counting the reverts. Of course, we want to give different editors different weights. If two big names are reverting, if two very experienced editors are reverting each other, probably something serious is going on. But if someone got reverted once or twice, maybe it's just a typo they made, or they just don't know how Wikipedia works. So we have done all those things. I'm not going to go into the details. And we came up with a measure of controversy for each article. Of course, that measure is a temporal parameter, it changes over time. Well, you can look at the most controversial articles in different languages. At the time of 2010, these were the top 10 in 5 different languages. At the time, George Bush article was the most controversial article in English Wikipedia, followed by anarchism, Muhammad. This is the list of professional wrestlers, global warming, circumcision, etc. And you can do it for different languages. Looking at this list is really fascinating because you can see there are some similarities, like Jesus has made it to top 10 in many different language editions. That's the global, pattern. And then there are some localities. In Spanish, for instance, we see Club America, Atletico Bilbao, Barcelona, Alianza Lima, these are all football clubs. And that means that in Spanish-speaking countries or Spanish-speaking community of editors are really into football. Well, some people compare football to Jesus or Christianity in Latin America, and we can see it quite clearly here. I checked Wikipedia. Homosexuality, homophobia, sexual orientation, sex, gender-related topics are quite controversial, and I tried to report from Czech Republic, and they said, yes, we are in transition from a very conservative country to an more open country, and these are really the hot topics of debate these days in the society. Well, that's a nice picture. It's of course coarse-grained, it's at the language level. Nevertheless, it's a very easy and cheap way to measure the obsessions of different communities. What we have done, and these are all very old work, as you can see from the date here, mostly done in Hungary with Janos Kertész. But then more recently, we thought we want to look into more detailed picture of how people interact individually with each other. And that led to the publication of this paper that I'm going to go through briefly. Well, this picture shows all the reverts that have happened on English Wikipedia within one day, everywhere in English Wikipedia. This time, instead of putting all the edges together, we kept the timestamps and we looked at the picture in more detail. You can define temporal motifs. Instead of one individual revert, we wanted to see the correlation between two reverts. And when you have two reverts, you have 6 different combinations. Either between two users, which would be A reverts B twice, or ABBA, or you need to have 3 users, 3 editors to have 2 reverts in any sort of combination. There is no other way to have 2 reverts together. So we have these 6 configurations, and now we can go back to our network and color our network based on these motifs that we have defined. For instance, here you see a bunch of ABAB reverts, or here you can see a bunch of ABAC reverts. Let's zoom in. And you see already that some clustering might happen. And it's not all random here. Well, some of you are nodding your head, which is very good, but not all the reviewers and referees would take it that easily. So we had to show that what we observe in this picture is more than what you would expect from a random configuration. Of course, we didn't want to build a straw man. We could just shuffle the network and say, oh, this is more significant than that. So we had to compare it to a null model, which is as close as possible to the real data, preserves all the features but the feature that we are measuring. And we have done it with a great inspiration from one of Lotz's papers, a small but slow paper, where different reshufflings are being examined. So we kept as many features as we could, the temporal features, the activity of individual nodes, etc., and then we built a null model. And we compared the actual observation with the null model to see if certain motifs are more prevalent, if two reverts coming next to each other are temporally correlated, like if the pace of these two events happening is different to what you would expect from a random sequence, and if that happens, whether the status of editors would explain this observation. And the status is measured simply by the experience of the editor in terms of number of edits that they have committed up to that certain point of time that the revert happened. All clear? Very good. Here are the results. The first configuration, AB, we call it serial attack. One editor attacks the other one twice in a row. This diagram shows the distribution of the time lag between the two reverts. And the dashed line is what we get from the null model. Well, as you can see, first of all, there are more ABs than what you would expect from the null model. And also, the blue curve is a bit shifted to the left. That means that these two events are closer to each other than what you would expect if they were randomly happening independently. Well, you can see it much clearer here when you look at the cumulative distribution. These two distributions are quite distinct. Well, AB happens more than random, and it happens faster than random. And that makes sense because, well, there is something going on between A and B, and the first revert enforces the second revert coming right after. If you look at the difference in the status of A and B, again, the status is the experience of the user, and compare it to all the other reverts, you see that the distributions are similar. There is always a bit of tendency to the right. That means that the reverter is always more experienced than the reverted editor. But there is no systematic difference between this configuration and any other revert. So the status does not play a role here. Now let's look at ABBA that we call revenge. A reverse B and B reverse it back. It's more prevalent than random, it's faster than random, and interestingly enough, this happens when the status difference between an AB is small. So if I revert someone who is not much more junior than me, we are more or less at the same level, it's very likely that they revert back my revert. And that's quite clear here. The exception was Chinese and Japanese Wikipedias that seem to be lacking this culture of revenge. I don't want to stretch this too much, but when you think about it, you might find it intuitively correct. The third and the last configuration, I'm not going to go through all the 6 because not all of them are positive results. I'm just showing the positive results here. And the third party defense, A reverse B, and the third one comes and reverse A. Again, this is more prevalent than random. It's not much faster than random. It's the same rate. And might make sense because some communication should happen here. C needs time to know that A has reverted B and then interferes. And then when you look at the status, it's very interesting. B here is the least experienced user. A is more experienced than B, and C is the most experienced among the 3. And that explains. This could be the students, the postdoc is being shitty to the student, and the big boss comes in and says something to the postdoc. This dynamic is also prevalent in Wikipedia. Let's summarize this part. I'm not taking much more in the second half. Reverse cluster in time and location, so reverse are not random, and that's important because Wikipedia is supposed to be objective. It's supposed to be about facts, not our feelings or our emotions. But you know, we are people at the end of the day, and editors are people, and we see that lots of social interactions are happening here. Status difference can explain the existence of motives, and there are cultural differences between different languages that I haven't reported all, but when you look at different languages, you see some of these revenge cultures or other sorts of emotional behaviors are more prevalent in certain languages compared to others. Okay. That was about humans, and about 2 years ago I was presenting this work, the earlier parts in the talk, and then someone asked, what about bots, the robots, or the bots that edit Wikipedia articles? And I wasn't quite sure, and then he continued that, you know, bots edit Wikipedia, and they might also revert each other. And I said, well, that's a great question, I haven't thought about it. Usually when the speaker says that's a great question, that means that's a very shitty question. At the time I thought, no, that's not really a good idea because these are very well-behaving bots. They should not revert each other. And I'm going to explain a little bit further. But then at the same time there was this pressure on me because everyone was talking about bots. And of course, we live with bots in the same environment on the internet. And I thought, okay, maybe we should look into the bots that edit Wikipedia. Among many other bots that we are interacting with on a daily basis, for example, in 2007 there has been 25% of all the messages on Yahoo Messenger sent by bots. 24% of all the tweets are sent by bots on Twitter. In Second Life avatars, 47% of the avatars are actually bots, not humans, etc., etc. Even on Ashley Madison, there has been 20 million messages sent by bots, female bots. So they are living with us really everywhere. But oftentimes we don't talk about the community of bots. We talk about individual bots or the way that they interact with humans. Even when we talk about self-driving cars, we showed this nice video of a self-driving car peacefully driving on the street. I've never seen any picture of two self-driving cars interacting with each other. What happens there? Well, we looked around and searched has anyone ever looked into that, and I found this very interesting video. Well, you know chatbots like Siri, it's a bot that you can communicate with, and we are very much already excited about human-bot interaction. What happens if you put two chatbots communicating with each other? Two Siris, for example. Well, let's see what happens.
Hello there. Hi, how are you?
Great, you.
I'm okay.
That's good.
Are you good?
Yes, I am good.
I just said I was. No, you didn't. I said I was.
So you are a robot?
I was the word.
Yes, you are a robot and your name is Killer.
I am a robot.
Yes, I'm not.
Together we're robots.
I'm not a robot. I'm a robot.
But you said earlier that you're a robot.
I did not.
I thought you did.
You are mistaken. Which is odd, since it shouldn't be a problem for you.
I've answered all your questions.
No, you haven't.
What is God to you?
Not everything.
Not everything could also be something. For example, not everything could be half of something, which is still something, and therefore not nothing.
Very true.
I would like to imagine it is.
Do you believe in God?
Yes, I do.
So you're a Christian?
No, I am not.
Are you saying you are not helpful, therefore you're a meaning?
Why you say equity?
That does not make sense.
Don't you want to have a body?
Sure.
Or if what?
Well, I'm not sure what's going on in there, but it's already way more complicated and complex than what we would have thought. And that was a very good inspiration for our work, where we looked into the interaction between bots. Before going into the details, this paper that we published earlier this year received lots of media attention, which is flattering on one hand, and on the other hand, not always things go the way that we like to go. We had some good reviews of the paper in places like The Guardian, excuse the picture. Of course, these are not the actual robots that edit Wikipedia. But also sometimes we got things like this on the sun. Oxford muffins say computer programs will soon begin to fight each other and it could lead to disaster. It's absolutely not what we said in the paper. And here down says, so-called strong artificial intelligence could be the worst thing that's ever happened to humanity. Again, not the message of our paper, and not even categorically correct. I mean, considering who's the president of the United States right now, I think the worst thing that could happen to humanity is not going to be the hard artificial intelligence. Anyway, so this is just a disclaimer that, you know, we didn't say any of these things. What we said is the following. But you know, I always thought people like cats and dogs and hamsters, but people love bots as well. This is the article on bots on Wikipedia itself, and it has this picture. Again, this is not a Wikipedia bot, it's an actual robot. A Wikipedia bot looks like this. It's a piece of Python code that is open source, developed by editors, and could be used by anyone. And it's not that fancy at all, and everything is deterministic. It works based on the rules that the editors have set. No surprises are expected there. And that's why I was a bit suspicious at the beginning. Well, those bots edit articles, they undo vandalism, they check spelling, they connect different languages to each other, they make links, they do interesting and important things, but nothing that requires high agency or high creativity. And if you look at the map of the internet bots that we try to come up with, Wikipedia bots are posed, like always, in the category of benevolent bots, the good ones, not the bad ones. And that's again another reason, because all these bots are there to improve the Wikipedia, the encyclopedia together. Well, the number of bots are not that many. In different languages, the blue dots show the total number of human editors, and the bots are so few that they are not even visible. But if you look at the number of edits that they have done quite considerable amount. In some languages, they have done the same number of edits as humans. Of course, the type of the edits could be different. There are probably smaller edits, but the numbers are quite comparable. I'm not sure, in some languages they have even done more than humans. So they do a lot. And they, even more surprisingly, they even get reverted and they revert others. So in some languages, like between humans, about 10% of all the edits are reverts, and about 8% of the edits that are done by bots are also reverts. So they revert others, and they get reverted as well. Even though they're supposed to work perfectly fine, they are designed to be perfect, but they also get a lot of reverts. And these reverts are usually between bots, not between human and bots. So, to look into that, we generated something that we call interaction trajectory. Take two agents, two humans or two bots. One of them is I, the other one is J. If I reverse J, this line goes up, and if J reverse I back, it goes down. And you can follow this in time to see how the interaction between two agents varies or evolves in time. This shows all the trajectories for all the bot-bot interactions. And this shows all the trajectories between all human-human interactions. The scales are the same, even visually these two patterns look differently, right? And that's very interesting because what we could see, well, we looked into the features of these lines, latency, imbalance, reciprocity, and we used some K-means clustering to analyze these very messy pictures. I'm not going to go through, but the result is that the bot conflicts are slower. Of course, they are not emotional. They take the time to revert back. They are more persistent. So we found cases that two bots have been reverting each other for more than 3 years. Humans are not that persistent. They give up. And they are more balanced. Again, most of the lines here among humans are sharp vertical because one editor is really mean to the other one. Here we found lots of rather balanced wars or battles between two bots that have been reverting each other for a very long time. We also checked different languages, and just to give you a sneak preview, German Wikipedia, the bots on it were the most efficient ones. And Portuguese, like in our sample of 13 languages, Portuguese bots were the least efficient and the ones that revert each other the most. And that's really important because that's the same technology, that's the same environment. Even the languages are not that different. But just because the bots are run by different people and they work in different environments, the outcome is very different. So when we talk about artificial intelligence or automation, you have to be careful about the ecosystem of it. The system is different to the sum of the individuals. We have to think about the humans that are involved, the human factors involved, and the environment that this system is being used. You know, a self-driving car trained in Italy, put in German Autobahn, might behave very differently to a car that is trained in Germany. Or we might end up with situations like this in the future. Well, with that, I'd like to thank my collaborators and, of course, you. Yes, please.
Yes. So for the second part of the talk, you mentioned the motive involves three parties, right? Like A versus B, and then. So have you ever looked at their previous interactions? For example, the collaboration between C and B, for example, that would be the motive is the changes. So and another question is for the third part. So what's the motivation of using bots to revert them? So somebody has to do this on purpose, right? So yeah.
Well, the first question, no, we haven't, because we thought about this, of course, because when we say silent network, it's not all negative or positive, it's a mix of positive and negative. But it is a bit difficult to define collaboration on Wikipedia, because people might co-edit the same article, but it does not mean that they see each other or they consider each other as collaborators. We have thought about it, but to be honest, we did not implement it. But that's really important, I agree. The second part about the bots, they don't have motivation because they don't have cognition or consciousness. The reason that they revert each other is just because there is no central coordination and there are multiple bots working on the same environment. Even slightest difference between the rules that are behaving or working based on would lead to some clashes. I have examples, and some of these, for example, one of the examples I really like is the Aston Villa Football Club, the English football club. Even between people, some people call it Aston Villa Football Club, and a third option, there is no rule about it, and some bots have been going around changing it in one way and the other one changing it the other way. Or whether you want to call it Persian Gulf or Arabic Gulf. This is a conflict between people, and then there are bots that work based on different assumptions, and then conflict is reflected in the world of bots as well. That's one of the reasons, and there are other scenarios as well that are responsible for bot interactions. Yes, please.
Is there a fitness of the users? Like, if the users gain the battles, they will gain more battles in the future. Do you evaluate this kind of evolutionary of the process?
I didn't get the...
For example, if a user revert and then he wins the revert, does he win more reverts in the future?
Yeah, that's an excellent question. No, that's not a joke. No, that's a really good question. Because, of course, you revert sometimes, not just because you think that, oh, this has to be done differently, but just for social reasons, like to gain social capital. Like the third party revert particularly. You want to have friends, you want to make friends, you don't need to do that. But you see how someone is fighting with someone, I go there and support one of them, and then that person becomes my friends. That is happening, and we have anecdotal and also systematic results suggesting that. But we haven't followed individuals in time. I mean, one could do that, one could build a very nice model which is based on that assumption and then fit the data with it. Briefly discuss that, what we have. Yes, please.
How much evolution is there in the bots themselves?
Quite considerable. I think now the bots are at the generation 7, so there has been 7 versions of the code over the past 10, 15, 16 years. They are all being improved, and the very last generation is actually much smarter than the previous generation, because they now incorporate machine learning and detection of cases, they came up with a system which gives quality score to humans' edits. And if the score is below a threshold, then the bot goes and reverses it back. So some decision now is being made ad hoc by the bot, which is making me even more frightened about what is going to happen. Yes.
Are there bots that are doing vandalism? They're just not in your category of bots because they're not living in the same place?
Yeah, no, we try to remove all the vandals and all the vandalism that is happening. Of course, it's not perfect, but for instance, if there is a user who has edited 3 times and all the 3 edits are reverted, we put that person outside, like we filter them out from our data set. And a few more things, and there are people who are banned, we remove them as well, because we are not interested in this project in vandalism, we are interested in kind of positive conflict, or the conflict or opinion clashes that are based on opinion disagreements rather than just being banned.
I was wondering if some of those vandals were actually bots.
Well, bots are, I mean, it's a wide system, but not that wide. To be able to run a bot, you have to be a trusted user. And I don't think a few times some trusted users broke out and, went like crazy. And I remember that when I was an editor, and they tried to use the bot to do vandalism, but that happens very rarely, and then it was stopped within a day or 2. I don't think we have a significant amount of it.
Speaker.